So good morning, everyone. The title of this presentation is Mass RCN, and my name is Kai-Ming He. This work is presented by Facebook AI Research. So before I started, I want to highlight that the image in these slides is a Venetian mask. So I believe Venice is a very lucky city for Mass RCN. So in the past few years, we have seen a lot of progress in the problem of object detection and also in the problem of semantic segmentation. However, the problem of instance segmentation is still very challenging. In the problem of instance segmentation, we not only want to detect the individual object instances, but we also want to have a mask of each instance. So to see how challenging instance segmentation is, we can show the number of entries in the COCO leaderboard and also in the Cityscape leaderboard. So in the COCO leaderboard, actually there are about 30 entries of object detection, but there are only 5 entries of instance segmentation. So similarly, in the leaderboard of Cityscape, there is about 60 entries of semantic segmentation, but again, there is about 10 entries of instance segmentation. So for the problem of object detection, in my understanding, why it has been so popular in the last few years, one of the reasons is that there are very successful meta algorithms that can support many of the improvements, and then it can get continuously improvement in the past few years. So one example in object detection is the fast or faster RCN system. So these systems has good speed, it has good accuracy, and they're intuitive and they're easy to use. So I believe they can support many research on object detection. So for the same reason, in the problem of semantic segmentation, we have the fully convolutional network of the FCN system, which serves as a meta algorithm for this problem. Actually, in my opinion, after the publication of FCN, almost all the semantic segmentation methods are kind of a fully convolutional network. So this demonstrates the power of the meta algorithms. So the goal of this paper is to present a method for instance segmentation, and we hope this method will serve as a meta algorithm, and we hope this method will have good speed, good accuracy, and also it is intuitive and easy to use, so it can support future research on instance segmentation and many other instance level understanding applications. So in the past few years, the instance segmentation methods can be roughly categorized into 2 families. The first family is driven by the success of the RCN methods. So for these methods, people usually start from some segmentation level proposals. And after that, some classifiers are trained to classify these proposals into the semantic categories. Another family is driven by the success of FCN. They usually started from some full image semantic segmentation results, and then they will learn some cut to divide these results into individual instances. So what is Mass RCN? Actually, it is very simple. It is just a combination of the best of both worlds. So Mass RCN is actually a faster RCN system with a fully convolutional network runs on each of the ROIs. So it is very simple, and we hope it will serve as a meta algorithm for this more challenging problem. So one of the properties of the Mass RCN system is its parallel heads. So we believe the parallel heads are easy and fast to implement and use and will help to facilitate research. So if we go back to a few years ago, in the original slow RCN method, actually it is a 2-step training system. In the first step, people train a classifier to classify between foreground and background or among different classes. And in the second step, people use the features to train a bounding box regressor. So this 2-step problem has actually been greatly improved and simplified in the fast RCN system, which trains a parallel head for classification and also bounding box regression. So Mass RCN is designed in a similar spirit. So in addition to the bounding box classification and regression head, we just simply add a parallel head for predicting the mask. So we believe this is a simple implementation. And another property of Mass RCN is an operation which is called ROI align. So ROI align is just a simple improvement of the very popular ROI pool operation. However, there is no any quantization in the ROI align operation. So we simply need to map our region into the feature map, and then we do bilinear interpolation to extract a fixed dimensional output. There's no any condensation, and so we hope there's no information loss in this process. So comparing with the very popular ROI pool operation, actually we would like to note that the original ROI pool operation was not designed for segmentation, it is designed for object detection. So maybe it is still okay because you just need a bounding box, you don't need the pixel-to-pixel accuracy. So, however, the ROI pool operation, because of the pooling, it may break the pixel-to-pixel alignment. So this may not be designed for instant segmentation. So we hope the ROI align operation can help to solve this problem. And another property of masked RCN is the usage of a fully convolutional head for predicting masks. So fully convolutional networks are designed naturally in a pixel-to-pixel alignment fashion. So we just simply need to use a few extra convolutional layers on each region of interest, then we can predict a very accurate mask. So here is one example. I show one image here, and I also show one region of interest, which has been warped into a rectangle. So this is the fully convolutional network output of a resolution of 28 by 28. It is pretty good. It is very well aligned because that's the property of FCN. And then we just need to resize the soft prediction, and then after some threshold, we have the mask for this object. So as I mentioned, actually, masked RCN is a meta algorithm. So it can support many implementations. So we also hope it can be compatible with many other improvements, such as cognitive mining or many improvements of the backbone architecture. So in this paper, we have used ResNet or ResNext as the feature backbone, and we also use the feature pyramid network or FPN as the backbone. So next, I'm going to show some results. So here are the object instance segmentation results on the COCO dataset. The first 3 entries are the winners of the COCO competition in the last 3 years. So actually, without bells and whistles, our masked RCN entry can be 2 AP better than the winner of last year. And also at the same time, our method can run about 200 milliseconds per image on a GPU, which is pretty good. And also, because our method is a meta algorithm, it can easily support the improvements of the backbone architectures. So for example, if we replace the features from ResNet to ResNext, we can see another about 1.4 improvements on this task. Actually, as a byproduct, the masked RCN system also improves object detection. So here are the results of bounding box detection on COCO dataset. So if we compare the ROI align operation with the counterpart ROI pool FPN baseline, our method has about 1 point improvement. So if we train the mask with the bounding box jointly, we can see another about 1 point improvement thanks to multitask learning. And again, our method can also improve by using better features. So actually, in the upcoming COCO competition this year, masked RCN is used by many of the leading teams to our knowledge. So for our team, our masked RCN entry has achieved a single model result of about 48% bounding box AP and about 42% masked AP. So more details will be disclosed in the COCO workshop. So next, I'm going to show some examples. So here is one of the masked RCN results. I believe this is a very challenging image because, for example, there are objects that is surrounded by other objects of the same category. This can be a very challenging case for semantic segmentation. So here is another example of the masked RCN result. So we can see that there are disconnected objects in this case. So it may also present a challenge for those methods that are based on grouping. So here is another example of the masked RCN result. We can see that our method can successfully detect and segment very small objects. So after seeing all these results, people may think computer vision is solved, but unfortunately it's not. So there are still many failure cases. So for example, the detection can still fail, and in case the detection fails, the segmentation may also fail. So there can be missing objects, and there can be false masks. And also, more importantly, recognition is not solved. So there are very usually recognition errors. So for example, master RCN recognizes this is a kite, but it is not. So master RCN can also be very easily extended to other tasks such as human keypoint detection. So the extension is very simple. We just need to view a single human keypoint as a one-hot mask, and then we can use our framework for this task. So in other words, it means our method is a single framework that can support bounding box detection, mask segmentation, and also keypoint detection. Next, I'm going to show some master RCN results on video, and this is just done frame by frame. There's no temporal smoothing. Here is another example of frame by frame master RCN. So in conclusion, we have presented master RCN, which we hope will serve as a meta-algorithm for the problem of instance segmentation and other instance-level recognition. So our code will be open source as Facebook AI Research's detection platform, and we hope we will do that after the CVPR deadline. And that's all. Thank you.
There is time for one question. Well, I have one question. So, have you tried this with classes that are not well localized, like sky, grass?
Yeah, I think in the upcoming COCO workshop, we are going to present another semantic segmentation system, which is based on a similar backbone of master RCN. And in that case, we believe we can just extend the system to be a multitask training system, which we hope it can detect both objects and stuff.
Thank you. Okay, let's thank the speaker.
Thank you.